I will be teaching in the first part of this lecture, EE 4204. Okay. So let me quickly show the assessment methods which you would be interested to know. Okay. So there are three components of, four, including the final exam. So there will be a lab component. The details will be posted later. This lab component or lab assignment is based on circuit programming. This is network circuit programming, where you will be sending some file from one system to another system, and you will be given some variation of your protocol by which the file can be sent from one system to another system, and you will be asked to measure some performance based on some metrics, and the details will be given to you slightly later. And this lab assignment will be carried out after the midterm break. That means from week 7 or 8 onwards. Okay, because I need to teach some topics before you get into the lab. And this lab, as I say, it's from week 8 to 13. Maybe week 8 or 9, you will have some lab practice sessions where you can practice some examples which will be given to you, and there will be graduate assistants and me to help you out. Okay, and week 12 or 13, there will be the demo of your assignment problem. Okay, so that's the end of lab assignment. The lab assignment carries, you can see that it carries 20 marks. And apart from that, there will be 2 tests. And the test 1 or quiz 1, which carries 15 marks, is on my part of the lecture topics. This is mostly is a MCQ type, multiple choice questions type. And there is another CA component for part 2, which Prof. Mehul Motani will be teaching, and he will be able to give you more details on the assessment. Mostly this will be some homework and also some test based. There will be final examination which carries 50 marks at the end, and this is all about the assessment. Any questions or doubts you have on this part? Yes? And looking at the syllabus, for my part, syllabus we should be available on the IVLE or Luminous. Okay, and you can see that there are few reference books listed for this. Okay, and we will be following mostly the first 2 books, Peterson and Davy. Okay, so and also the second book by Gross and Rose. And of course, these 2 books have different approaches. One is bottom-up approach, the other one is top-down approach. The things will be clear slightly later, but network course is a well-established course. Okay, and you can refer any book of your choice. Okay, I list few books here, and if you are not happy with these books, you want to refer other books, you can do so. Because all the books will discuss the same kind of topics, because the protocols are same, algorithms are same. Maybe the presentation could be different, examples could be different, the figures could be slightly different, but the concepts are more or less same everywhere. Okay. For my lecture, I will be mostly following book number 1 and also book number 2. Okay, some lecture notes are taken from other books as well, book number 3 and 4 as well. So when I provide you the lecture material, I will highlight which books I am following for that particular lecture topic. Okay. Again, to explain it more in details, you can follow the lectures closely. Okay, I believe lecture notes are sufficient, but I would always recommend the students to go and read the books to enrich your knowledge, okay, for better clarity and to understand more on that particular topic. You are always welcome to contact me by email or in person, okay, to discuss more on the topics. If you have any doubts or anything, you are always welcome. Okay, and at this stage, explaining the syllabus topics one by one, okay, may not be very helpful in the sense that you may not be able to understand. So let me give a brief overview of what we are going to teach in this course. Okay, so if you look at networks or computer networks, okay, and the names, you can see different names like communication networks, computer communication networks. So they all talk about the same. But when we say networks, that means for what purpose we are using networks? We are using networks to transfer a piece of data. Okay. Let me not go into the terminologies. Let's say we try to transfer some data from one end to the other end. The data or information could be in the form of web pages or in the form of movie clips or files or email data. Okay, there are different forms. Okay, but we want to transfer from one end to the other end some piece of information or data. Okay, is that fine? But it's not that simple. How it happens, how the data transfer happens from one end to the other end. What are the different elements or building blocks or the devices involved in ensuring that the data is correctly transferred from one end to the other end. Okay, and we have some requirements also. Let's say you want to browse a website. Okay, you go and use browser and you try to browse some web pages. What you require is that once you click, okay, you expect the network to respond quickly. How quickly? It depends. Okay, obviously we don't want to wait for a minute for a web page to load. Am I right? Similarly, when you send a message, even if it's an online social network, okay, could be WhatsApp or Twitter or any other network. So you want it to be transferred immediately, instantly. Am I right? Immediately means it may be milliseconds or seconds should be fine, but we don't want to wait for a day or hours to transfer the message. Is that fine? Similarly, if it is a real-time one, let's say you are doing voice chatting or video chatting, we want that happen immediately. You don't want to see any lag in the transfer of video, image, or the audio. Is that fine? But how it is done, how it's implemented? Okay, there are different levels or layers, okay, which cooperate themselves in the network, okay, or different devices. Okay, so they all do different piece of jobs, different sets of functions. Okay, for example, when we transfer a file or a piece of data, image or video, whatever it is sent through the network. It is sent through different links. Could be wireless links or wired cables, etc. There is a possibility that some bits may be corrupted when it is transferred. Okay, 1 may become 0, 0 may become 1. That means the message which you are sending or you are trying to download, okay, may be corrupted, may be changed when it is transferred through the network. But as a user, we don't want that to happen. Am I right? Maybe if it's a video file, one or some bits lost can be okay. Even if it's a distorted image or video, we will be able to make it out. But if it is an email text or let's say if it's a bank transaction, this, that, we don't want any, even one bit error we do not want. Am I right? But there are errors introduced in the network. So we need to implement, okay, some functions, some protocols, some algorithms, okay, in the network to make sure that the data is transferred reliably from one end to another end, maybe within a reasonable time to meet all the requirements. Is that okay? So, so these functions are implemented at different levels, layers, maybe on a link basis. Okay, when you send, let's say, from this host to another switch or router, or switch to router, router to router. So it can be done at that level, or it can be done at end-to-end level. That means from one end host computer to maybe another server level. Is that okay? So accordingly, we divide the whole network functions into different layers, starting from, let's say, physical layer, how the bits are transmitted as signals. Okay, then maybe, let's say, layer 2, layer 3, at the level of link, certain functions are carried out. At the routers, for routing the packets, how it should be routed from one end to the other end. There are many possible ways to route. There are many possible routes. Which route or path it should take. Okay, so there are some functions associated with that. Similarly, there are some functions associated with guaranteeing reliable delivery of data. Okay. So accordingly, we divide this into different layers of functions. Some layers of functions are taught by me and some are taught by the other lecturer in part 2. Okay. So with this introduction, we can start with the lecture. Okay, we start with the basics of networks. Okay. And this week, this lecture and the next lecture gives an overview of the entire network and various functions carried at different levels. Then up from lecture 3 onwards, we will go into the specifics of the individual layers and other things. Okay. And for this part of the lecture, I follow these references by Cross and Rose and also Peterson by Davy. Okay, I will try to give the references for each lecture notes. Okay, and most of the figures are taken from the first book. Okay, okay, let's start with this question. Okay, what is a network? It's a formal question. So how to define a network? When we say a network, so we can say it's a set of systems interconnected by communication links that's primarily used for information transfer. So you can notice that there are few terminologies used. It's a set of systems. So what are those systems? Next, interconnected. So a network should be connected, otherwise it's not a network. Okay. So interconnected by what? Communication links. So what are those links? That's the next question. Then what is the purpose? The purpose is to transfer information. What is this information? Why it's transfer? It's different from data. Maybe to put it simple words, when you attach a meaning to piece of data, we can call it as information. Okay. Let's not go into those details. What is a system? End system. Switch, routers, hubs. Next, what is an end system? End system or end host, we can also call it as end host or end system, okay, is the system, okay, where the applications are running. That is the end of the whole network. So example, our computer. This computer, when it's connected to the network, it's an end system because it is at the end. When you say at the end, it is the source or destination of the data. Okay, is that fine? So when you try to transfer a web page from a remote web server, okay, on one end you have the computer. Okay, this is the receiving end because you are going to receive the web page here to display. And on the other side, on the server is also an end system. Let's say there's a web server from where the web pages are stored and from where the web pages are sent to you. Is that fine? So these are the end systems. But nowadays, end systems need not be just computers or servers. It could be notebooks, laptops. It could be tablets. They could be smartphones, because smartphones are also end systems now, because when it's connected to the internet, okay, you run some applications, okay, so by which you can browse, you can do chatting, audio chatting, video chatting, okay, and online social network. So smartphones are also an end system. Then all the smart system devices like smart cameras, smart TVs, okay, which could be connected to the internet, they also become end host or end systems. Is that fine? So no longer we can call this network as computer network or computer communication network, because we don't just connect computers, we also connect other devices like TVs and other things, mobile phones, etc. But still we retain the traditional name like computer networks or computer communication networks. So let's not worry about the name. Okay. Links. Links could be wired or wireless links. Okay. That means you can have a physical coaxial cable or fibers to connect to systems, host or switch or routers, or we can connect through wireless means, let's say Wi-Fi or 4G, etc. Okay. And when we say it's used to transfer information from one end to the other end, it could be simple text or it could be audio, video, okay, and pictures, graphics. So there are many different kinds of data or information which are transferred across the network. Network applications, I don't need to mention, we all know for what purpose we are using the network. Okay. Let's look at the nuts and bolts of internet, maybe the building blocks, okay, of the internet. What constitutes an internet, how it looks like as a whole. Okay. So if you look at this figure, it's basically a simplified figure of the network. Okay. Network is actually more complex, but the purpose here is to look at different kinds of networks and different kinds of the end systems which are part of the network. Similarly, different kinds of systems, other systems like routers, switches. Okay. So you can see here there are some computers. Okay. There are some computers, and some computers are directly connected through wired means, and some computers are connected by means of wireless. So you can see here. Okay. And these computers are basically the end hosts. We can say that millions of devices, basically they are computing devices. Okay. Need not be just computers. Even smartphone or smart TV, if they do some pieces of computing, they also become like a computer. It's a computing device which can be connected to the internet. Okay. Sorry. So you can see that there are systems which called end systems, which I already mentioned. They are also called host or end host. Why they are called hosts? Because they are hosting network apps. Apps means applications. Okay. See, for example, when you use a computer to let's say browse the web pages, so you are using an app, web browser. There's a web browser app, okay, so which you use, maybe Chrome or let's say Internet Explorer or something, so which is used, which is running here, which will connect to some remote server, okay, from where you get the web pages. So the remote servers are also end hosts because they are also, there's the other end of our applications which are storing some pieces of data, and they are transferring data from there to our system. Is that fine? And these servers are also computing devices. Maybe they have computers, CPUs, storage, etc., etc. Okay. And as I said before, there are different kinds of communication links. It could be wired communication links like fiber, copper, radio, satellite. Sorry, fiber, copper or wired links, radio, satellite communications. They are all basically wireless communications. Okay. And when we say that data is communicated from one end to the other end, of course data is plural, but sometimes we use as a singular one. Okay, don't worry about it. Okay. So data is transmitted from one end to the other end. It's transmitted in the form of bits, ones and zeros. Ones and zeros. Now the question is, how many bits we can send from one end to the other end in 1 second? That tells what is called the transmission rate or data rate, bits per second. For example, when we say 100 Mbps, okay, let's say my computer has 100 Mbps interface, network interface. That means it's able to transmit and receive 100 million bits in 1 second. Is that fine? Let's say at our home, okay, I have 1 Gbps fiber broadband network connection. That means may not be from individual device, okay, from your home, maybe from the router or something. You should be able to transmit and receive 1 gigabits. That is 10 raised to the power 9 bits per second. Okay. Individually your devices may be 100 Mbps or 10 Mbps, but put together, okay, when it goes out on a fiber link, it could be 1 Gbps. Okay. So that's called transmission rate. That's related to what is called bandwidth. So later we will look at, that's a small difference between bandwidth and transmission rate or data rate, though they are related. Okay. And you can also see that there are some switches or routers. These are the switches or routers, okay, which are also part of the internet or networks. Okay, and these switches are basically, when we say switch, the meaning is that it takes some data from one input port and it switches or forwards data to another output port. For example, you take this switch or router, it takes data from this port. Okay, maybe you can imagine like a box with many ports where the cables are inserted into this. So data are received here and it can be sent to this or this. Is that fine? So, but the decision has to be made whether the data should be sent here or here. Maybe based on some routing protocol, it will make a decision. Okay, send through this port instead of this port. Okay, this may be more efficient. Maybe it may be a shorter path when you go through this way. Okay, so this is called switches. Okay, there are some differences between switches and routers. We will look at them later, but these are also key components of a network. Okay, now look at this figure. You can see different types of networks here. What are those? One, home network. Okay, when you go home, okay, inside the home there's a network inside. Okay, is that fine? Particularly developed countries like Singapore, so almost every home has a network within that. Okay? That means once you go there, you have different phones. Okay, maybe let's say there are 4 members, everybody has some phone. Maybe let's say 4 of you share a room in the apartment, everybody has a phone. Okay, so there are 4 end hosts. There may be some laptops, maybe some smart TVs, maybe some smart game consoles like PS4, Xbox, all those things. They are all connected to the network. So maybe we subscribe to, let's say, Singtel or StarHub, M1, MyRepublic. I mean, there are different telcos to which you can subscribe. Okay, so we can have fiber broadband or maybe other kinds of cable-based ones, ADSL from Singtel or cable modem from StarHub. Okay, so we can have different types of modems. Okay, and there is a wireless router sitting there in our home. So you can see that there is a wireless access points in the home to which, okay, all our systems are connected. It also might have the LAN or ports, wired ports, okay, to which we can connect our systems directly through cables. Usually wireless speed is smaller compared to the slower, okay, compared to the wired connectivity. Maybe smart TV and game consoles can be directly connected to the router through cables, LAN cables, and other devices like mobile phones and laptops, okay, which we do not want to connect through cables because we are moving here and there with the phone, right? So we can use wireless connectivity. So you can see that there is a wireless access point at home. Similarly, such wireless access points can be seen in the institution network or company network. So you can see wireless access points are placed here and there, maybe in our campus. So you can connect your phone or system wirelessly to the access point. Am I right? So that's a wireless connectivity. Similarly, even in the institution network or enterprise network or company network or campus network, okay, you can have either wireless connectivity. So this is the wireless access points to which all our systems are attached by wireless medium, some Wi-Fi or something. Okay. In other words, at home or the institution, we can also have wired connectivity. See, for example, in a company or institution, you go to the lab or let's say our staff offices, etc. Our systems, this kind of systems, they are connected by cable, not by wireless medium. Okay. So both wired and wireless connectivity or communications exist in the network. Okay, inside institution, yes, or in the home. And you can also see other kinds of networks. Mobile network or cellular mobile network. Okay, that means once you go out of the campus or go out of your house, you cannot connect to the Wi-Fi. Am I right? So then you turn on your mobile data if you want to access the network. So 3G or increasingly 4G, maybe 5G is coming. Okay, so that means your system your phone is connected to internet through what is called the cellular tower. So there are cellular towers installed here and there. So our system, our phone is attached to that tower through which you are able to communicate or you are able to use the internet services. So these cellular towers at the back end, they are attached to some routers, okay, and which is connected to ISP network, service provider network. So there are many towers which are connected by what is called ISP or service provider network, internet service provider. And the service providers can also be at different levels. Maybe small countries like Singapore, we may have just one level of service provider. Big countries may have regional service provider, global service providers, so maybe at different hierarchy. Okay, so the purpose of this slide is to show that there are different elements which are involved in the network. Similarly, there are different kinds of networks which exist in the as a whole in the internet. Okay, any doubt? So let's see how data is transferred from between two hosts. It's again a simplified example, but it gives an idea of what is happening. Okay, when we say host, as I said before, it hosts, it is hosting the applications, apps. Okay, whether it's an email based application or web browser application or online social media kind of applications or any video chatting, streaming applications. Okay, so they are all apps, applications. Okay, then there is one host at one end, let's say computing based host, and the other side usually we communicate to a server. Okay, whether you transfer through email or web browsing, or let's say you are trying to stream a video or chat, usually the other end is a server. Is that fine? You send to a server, maybe the other party also may read from that server to the other side. This could happen. So, but the communication is bidirectional in the sense that this host can be a sender, it can send a piece of data to the server. Similarly, server can also send a piece of data to the computer host. But most of the time, or in terms of volume of data, we download more compared to upload. Okay, so maybe you can imagine that, let's say this is the sender host, this is the receiver host. As I said before, actually both are communicating. Okay, but in terms of maybe frequency or volume of data, so mostly we are at the receiving end. We try to download rather than upload. But that gap is reducing. We also now tend to upload more data in the form of maybe more video clips, okay, pictures, images, high definition videos. Okay, that means we are also trying to upload more, trying to send from one side to the other side. And you can see that this host is connected to an access network. It's an access network. Access network, okay, access network is the network which provides access to internet. Okay. So at home, let's say we have fiber broadband or Singtel's ADSL based service, or let's say StarHub's cable modem based service. That's an access network. Maybe in the campus, okay, you are attached first to the Wi-Fi. This is an access network. Wi-Fi is an access network. That's the first point or the last end, first link or last link, which is used to connect to the internet. Okay, and this could be wired or wireless. As I said before, maybe in the lab, okay, or the offices, we use wired network to connect to the internet. Okay, or it could be wireless when you are on the move here and there. Now you can connect to the internet. Then the data is sent through access network to the core network, which is basically a wired network. This is a network of routers and switches. So maybe you can imagine after your wireless connectivity, at the backside there is a network of routers or switches. Then outside the campus, okay, the service provider has his own network. Okay, that we can call it as core network. It's a service provider network kind of thing. There are many such core networks through which data flows. okay, maybe the same country or different countries, different continents, until it reaches the end access network. There's access network at the other side, to which the host is connected. Okay, and usually the data which we sent is split into different packets. This is the data or the message, and these packets are sent one by one from one end to the other end. Okay, so this is explained here. Any doubt? Any doubt? Okay. Now, what are the requirements? Okay, let's say, as I said before, network provides a suite or collection of different functions or protocols, algorithms, okay. They all cooperate, work together to achieve one goal. What is that goal? To transfer data or information from one end to the other end. But there are different requirements depending on the applications. As I said, let's say bank transfer application is very critical. That since we cannot tolerate even a single bit error. Okay. Similarly, there are other requirements in terms of, let's say, video. Video means we don't want any lag. Okay. We want a reasonably good quality. Okay. Quality of viewing. When I view the video, okay, there should not be any lag, particularly when you do video chat real time. Okay, it's not that you tell something, then after 1 minute you get a response, or after even 10 minutes, even if it's a 10-second delay, we cannot tolerate that. Okay, you get bored after some time. Is that fine? Okay, so what are the requirements? When you try to meet the requirements associated with, there are problems. Okay, deliver data with an acceptable delay. As I said before, how do you define acceptable delay? It depends. It's quite subjective. It need not be in microseconds. Okay, could be in seconds for applications like web browsing, or let's say email transfer. Let's say you transfer an email or some message. If it's transferred after 1 second, 2 seconds, 3 seconds, should be fine. I mean, we can tolerate. Okay. But if your friend sent, okay, I sent some message to you, I emailed some interesting message to you or some pictures to you, and that he already said, but you are looking at this, you are not receiving, okay, that means it has not reached the server yet, or which is visible to you, okay. So if it takes few minutes, okay, but more than few minutes, we may not be able to tolerate the delay. But as I said before, for real-time applications like video chatting, okay, or let's say there's a video conferencing, okay, in real time, many people are participating, okay, so when they talk or when they exchange some information, it should be immediate. That's what we expect. Okay, so there are requirements on delay. Similarly, how we can use the network resources efficiently. Maybe on this network provider or service provider, he would be interested to use some techniques or protocols to use the resources effectively, maybe in an efficient manner, for improved performance. Okay, that means the delay should be low. That is, the network should be able to transfer data within a short period of time. At the same time, it should be able to provide high throughput. High throughput means how much data is transferred in 1 second. Whether you are able to transfer 100 million bits or 1 gigabits, okay, or 100 billion bits in 1 second. So how many bits the network is able to transfer from one end to the other end. So these are some requirements. Then reliability. That is, data should be transferred reliably from one end to the other end. As I said before, okay, the networks or links, communication links, whether wired or wireless, okay, they all introduce errors. They are prone to errors. Errors are bound to occur. We cannot say that I provide a wireless medium or wired link. Okay, I am 100% sure there will not be any error when you transmit from this end to this end. No, it cannot happen. Okay? So what are the different kinds of errors? Bits can be damaged. Maybe one bit, 1 or 0. 1 may become 0, 0 may become 1. And the network should be able to handle burst errors. Burst errors means continuously few bits, a burst of bits are affected. And sometimes the links, on the link there are no errors, okay. All the bits, the packet has been received at the router, but let's say the router is congested, it's not able to handle, some packets are lost. That could happen, which we discuss later. So packet can be lost because of congestion. That cannot be tolerated by the user. Network cannot say that, oh, my network is congested, okay, your message may not be delivered correctly, okay, some bits, packets may be lost, don't worry about it. We will be worried about it, we are concerned about it, right? So what we want, okay, packets may be lost because of congestion, but you take some measures, extra measures to make sure that, okay, the lost packets are transmitted again. Is that fine? Similarly, links and node. Node means here, let's say routers, okay. The communication link may fail, okay, and the routers may fail. Suddenly some port is not working. Let's say some switch is powered off, okay, or it became faulty. Let's say some link is plugged out, or maybe under the ground some links are laid out, okay, for some reasons, okay, man-made reasons or natural disasters, the link is cut. Okay, so packets or data are lost. So how to handle that? So network should provide some extra measures, necessary functions, and messages should not be delivered out of order. As I said before, when we send a message, it's split into different packets. Packet 1, packet 2, let's say there are 100 packets. So all 100 packets should be received at the other side of the application in the same order, 1, 2, 3, 4, 5. Okay, but it may so happen that when they are sent to the network, packet 2 may reach first before packet 1. Might happen. Is that fine? But for the user, when ultimately the message is transferred to the user, packet 1 should appear first, then packet 2. Is that okay? Otherwise your message will be scrambled. Your photos or images will be distorted. Okay? So some extra functions the network should do. What happens if the packets are received out of order? So it should do something to put them in order back, so that as far as user is concerned, all the packets, all his data are arrived in the same order. Is that fine? Finally, there are security requirements. They are increasingly becoming more and more critical. Okay, there could be attacks. There could be loss of information. There could be leakage of information. There could be unauthorized access. So network should take some extra measures. Okay, they should implement certain functions to make sure that the network is secure. How to guarantee 100% security? Still, it's a big question mark. Okay, is that okay? So these are the requirements and associated problems which the network designer should address. So there are many protocols, algorithms in place to answer all these questions, which we will discuss one by one in this course. Okay. Okay, already we are late by a few minutes. Let me stop here. Okay, so if you have any questions about this module or about whatever we discussed today, I can spend some time here. If you don't have questions, those who do not have questions may leave. Others can stay here. I can spend some time to answer your questions. If you have any questions on the assessment or any other on the whole module as a whole? No questions? Okay. So if there are no questions, let me stop here. And before we leave, I would like to highlight that or announce that there could be a makeup lecture, because we lost one lecture on Monday. I'm trying to schedule it on this Friday, but not yet confirmed, because I'm yet to find a free lecture theater and etc. etc. So if it is found, maybe later today or tomorrow I will send you an email. Okay. Did you receive email which I sent through the Luminous when I post the lecture notes, the first set of lecture notes? Okay, that's good. Are you free Friday 12 to 2 p.m.? Very few, is it? You have class in other faculty or here? Theoretical faculty, is it? Which class? Lecture? Oh, because I thought usually we don't schedule lectures on Friday 12 to 2. Okay, of course, it's not yet confirmed. Okay, otherwise maybe Saturday may not be convenient, is it? How many of you prefer Saturdays and other things? Anyway, don't worry. Okay, even if you miss a class, I will try to webcast it. Okay, but wait for my email. It's not yet confirmed. If it's not confirmed this week, maybe it could be next week. Okay, but anyway, I need one makeup lecture which we lost on last Monday. Okay, see you then. Yes? You want to webcast or no? Students always want to webcast. We are also happy to do webcast. But the potential problem which many lecturers complain is that after a few weeks, the attendance is going down, down, down. I can webcast. Would you be able to attend lectures as much as possible? Okay, I cannot force you to attend the lectures, but I always suggest you, if you attend the lectures, then watch the webcast. This will really help you, rather than miss the lectures and push things towards the test one day before the test or one day before the exam and sending all kind of questions in the midnight when the examination is next day morning. Sometimes I used to get questions in the midnight, 12 o'clock, 1 o'clock. Okay. What I would suggest, okay, we will webcast, don't worry. Okay. But at the same time, you try your best to attend the lectures where you can benefit more. Okay. And for some reasons, like you are sick, or maybe let's say you have some other important task, okay, some sport event or something you are presenting, that's fine. Okay? So otherwise, we will webcast it, don't worry. You can go and check, maybe sometimes 1 or 2 days later it will appear, but you can check Luminous, okay?